Hi everyone, and welcome to my video. In today's video, we'll be talking about how to correctly set up your tilting servos on your VTOL planes. I'm going to be doing it on the T2 Cruza, but you can probably do this on any other VTOL that you have that has this tricopter configuration with tilting servos, because most likely your servos will not be ideal perfect servos and you will have to do a little bit of trimming. And so what I'm going to do is I'm going to explain my setup procedure for this, because I think that the wiki that's on INAV is not necessarily perfect. It gets you to a very good point, but it doesn't get you all the way. And so here are the steps that you need to take in order to complete everything, let's say, perfectly. So one of the issues, or one of the key issues that you will most likely face is that when you set up everything, your tilting servos will not tilt in opposite directions as they do here. Most likely, what's going to happen is that your servo will be vertical, and then when you tilt one servo forward, like this one, it will go forward, but the other one won't go backwards. And so what will end up happening is you will get some yaw authority. However, every time that you do yaw, your plane will go slightly forwards. And that's not really what we want in a situation like this. So we need to figure out how to set it up properly so that both can tilt. Now, if you follow the wiki guide, it will get you to a point where this will work, but it won't work fully, and it won't do this because it's missing one crucial step, and that's the endpoints of the servos. For the Hewing tilting servos, which this is equipped with, so this is the VTOL kit for the Hewing T2 Cruza, and these servos are a bit specific in that basically the servo tilts exactly 90 degrees between 1000 and 2000 picoseconds, which is the PWM value or frequency. And so you only have 90 degrees of motion. However, due to gear alignment, you will notice that one of the servos might align correctly to the 90 degrees, whereas the other one might be just slightly off. And of course, we need to correct that. So that's another thing that you need to keep in mind, and most likely you will have that in other servos. But if you have a servo that's mounted, for example, here, and is using a control rod to shift the angle, then it might be that you can just change the length of the control rod and then adjust your servos that way, which will give you more, let's say, correction room on a hardware level rather than the firmware or software. So that's possible. But with these, because everything is inside the servo and everything is inside the mount, that's just not possible. So we have to do it in the configurator. And unfortunately, most of the videos that I saw online, I was not able to find a good way, in which I could properly set this up and follow the guide. So I thought, I'll figure it out and I'll make a guide myself. So if we move to INAV, I know this is not ideal, and let me try and adjust the camera so that you can see this. And I know it's going to be shaky, but I might be able to do like a secondary tutorial on how to set this up. So if we go into the Mixer tab, one of the things that you will have set up in the very beginning is that your stabilized yaw and your max will be at -100 and 100, and your weight for the stabilized yaw will be -50 and -50. Depending on your servos, you might have to look at that. Those values might change if you need to reverse the servo channel or stuff like that. But anyway, long story short, these values will change. But we're not going to change these values primarily. We're going to leave them at exactly -100 and +100, because we need to go into the Outputs tab and adjust the outputs accordingly. So in order to adjust the outputs, what you need to do is you need to, in my case, this is servo number 4 and servo number 5. Servo number 4 is for the left wing, the tilt motor, and servo number 5 is for the right wing. So in order to adjust these values correctly, the first thing that you need to do is you need to figure out your weight, and your weight will be minus 50 and minus 50 if you set it up. That way it might be plus 50 and minus 50, depends on your servo again. But the most important thing is that you need to tune the minimum and maximum values so that they correspond to the following. If we have a look at this, and if we rotate one of the rotors to the perpendicular or parallel position, let's say, then when we tilt it backwards, we want to just be a tiny bit over the plastic, because otherwise what's going to happen is the servo is going to, well, as the motor turns, you're going to have binding, or, you know, this will just crash into the back and it will, you know, but you've got to leave a little bit of a gap. You can't force it all the way down because, as you know, these props are flexible. So during your maneuvers, they are flexing as your axis of rotation is changing. This is flexing, and you want to leave enough area, enough of a gap so that it can flex and not touch, but you do want it to tilt backwards. So in the initial state where we have the max value set at minus 100 and plus 100, this servo will be all the way at the back. So now what we're doing is, when this is at 100, the easiest way to do it, if you don't want to keep holding your yaw stick to the side, then you've got to make sure that it's at minus 100, and here you can start adjusting the value, okay? So you can see here, I've got these values which are going up and down. I want to make sure that I'm adjusting those. Now, mine do not go all the way to 2130 or 890. Instead, you can see that they are slightly different, and there is a reason for that. The reason is that I have reduced my weight such that both of these tilt as much forward and back as the opposite side. Because if you don't do that, then what will happen is, as you're tilting backwards, you reach your limit. So this will be your hard limit, but then one side will continue moving forward while the other one has already stopped moving backwards. And that's not what you want to do. You want to have them move equally in both directions, but we'll get to tuning that in just a moment. So the first step is you need to make sure that these values correspond. The minimum corresponds to the minimum on this side, and depending on your servo setup, the maximum on the other side. So in my case, it's min and max because I've set them up that way. You can also have it set up differently, where you reverse the servo. That's also possible, and then you have both as min and both as max. I might even do that in a later edition of this setup. I'll post the file on my shared Google Drive, and then you can have a look there as well. So you can copy the settings. And the way that I've set this up, just so you know, is I have set these two channels that go to the servos. I've hooked them up to another receiver, FlySky receiver, that I know is outputting exactly 1500 ppm or PWM. And so when that happens, I know that this is supposed to be at 45 degrees, okay? So then I plugged in the servo, I plugged in these CNC aluminum parts, and then I continued the assembly because I knew that at 1500 they need to be at 45 degrees. And even then I had some issues because they weren't exactly at 45 degrees. However, if you set things up, you don't need to worry about the servo mid, because the servo mid will be calculated by our transition mode. So when we go into transition mode, if we get all the other values correct, then we do not need to worry about the transition mode being exactly at 45 degrees because everything else lines up. And so transition mode is exactly halfway, and exactly halfway means 45 degrees. We just have to make sure that it's actually 90 degrees. So what happened actually with mine, just as a side note, when I plugged all of this stuff in, because of the way that the CNC part was machined and the way that the servo was constructed on the inside, this servo was tilted slightly downwards, and the other servo was tilted slightly upwards. So what that would do is that would roll the plane when in horizontal mode, and when in vertical mode, it will cause a constant yaw, which would have to be counteracted by one motor going back or forth, but because it can only go forwards, the plane would have ended up moving forwards continuously until I transition into actual forwards motion. But that's not what we want, right? So, going back to the mixer, this is essentially the main thing that we need to tune. It's this parameter, the minimum, this parameter, which is the maximum, and then again the maximum and the minimum on the other side, to make sure that the servo is actually behaving the way that it's supposed to be behaving. Once you have tuned the min and max values, meaning you are in the vertical position, you have no movement, so when we move this, you can see that they're trying to counteract that because it's yaw stabilized. If we have the craft sitting perfectly level and nothing's happening, we're not in horizon mode or anything like that, then what will happen is when you tilt to the 45 degrees, we should see 45 degrees. And when you tilt down, we should be in the down position. Now, as you can see, that obviously changed because it changed into plane mode and not tricopter mode. But that doesn't matter because the outputs are still the same. They will always be the same based on both profiles, not just one profile. And then you tune the 90 degrees here. Basically, you tune it to be level. And once you have that tuned with the min and max values, then you'll have, these won't be in this position, okay? These won't be here. They will be slightly pointed backwards, okay? They will be pointed backwards as much as it can go, okay? And then the next step will be to tune the mid position. Then you go back to your mixer. You go back to your mixer here. And you go down to the max parameter, and then you start adjusting the max parameter, which is like a fixed value. In my case, it's minus 83 and plus 83. That's just what it worked out to be. And that's the fixed value that they are at when the servos are in this position. I hope that makes sense now, because previously we ended up with the servos like that. That's not what we wanted. We wanted them to be exactly like this. We can do a little test if you want. I know that this value is 83, so I'll change this to 100. Or minus 100 and 100. And you'll see exactly what I mean. So now, you see that both of these are tilted backwards, right? Because they are now at their furthest back position. And this will allow only one of them to move forward, you see? So with minus 100 and plus 100, we don't actually get the correct range of motion that we should. But, of course, we can go back. And as I explained previously, let's just connect. Go into the mixer tab. And in my case, it ends up being minus 83 and plus 83. Now, technically, this doesn't need to be minus 83 and plus 83. You can leave these at 83, for example, an exact value of 83 and 83. All you have to do for this particular plane, because of the way that the servos are set up, they're mirror image to each other. So then you need to go into the outputs tab and make sure that it's reversed. So one of the servos, one of them is reversed, whichever one that might end up being. In my case, I'm just going to leave it at minus 83 and plus 83, just to continue this demo. I might change it afterwards. But anyway, now you see, when we do our yawing, both of them are actually yawing. So I think the INAV Wiki is very useful and helpful, but I think this part, it gets slightly wrong, because you're supposed to have 90 degrees of your servos when they are not at their full range of motion, but when they are between 70 and 80% of their range of motion. And this will depend on the size of your blades, how much it moves per PWM value, you know, stuff like that. So how many degrees per PWM or per 10 PWM, you know, it's a bit complicated. The math behind it would be a little bit more complicated, but the essential part is that. And I think that's a little bit of a mistake in the INAV Wiki. I hope these guys will see the video and maybe change that. Maybe I'll add a suggestion for an edit, for a better tutorial on how to do this. But this is the correct way that they should be operating. And then, like I mentioned previously, one of the issues that you might be having is you need to tune the weight on the yaw stabilization. So if we go into our mixer, I'm talking about this value here, -35 and -35. Maybe we want that value to be greater or smaller. It just depends. If we make it 50 and 50, what will end up happening is, as I reach the bottom on that side, the other side continues more. So we want both sides to be moving equally and at the same time. Just to show that, let's put them like this and make sure the camera's in the center. So you can see these are moving the exact same amount in both directions. And that's important because otherwise what will happen is if one side goes forward a bit more or goes backwards a bit more, instead of your craft yawing or just spinning around its own axis, it will start to also move forwards. And that's not what you want. So yeah, that's pretty much it. If you found this video useful, you know what to do. And if you have any questions, please feel free to leave them in the comments below. I'm probably going to write up the procedure in the comments, and obviously I'll put a link to my setup so that you can have it in a download section. There's also going to be a download for this STL file, which I promised in a previous video. If you want to have the gimbal, I've edited this STL such that you can print it in two pieces. You can see that there's a little bit of a lip here. So this gets printed separately, that gets printed separately, and then the O3 air unit can fit nicely on the inside. You can see it there. So it gets nice cooling and so on and so forth. And it's easy to access because all you need to do is just slip it off. So anyway, that's another topic. But I hope you found this video useful. And yeah, I hope you learned something. Thanks for watching. Alright guys, so I did modify something in the setup and I'd like to share that with you. I didn't like how the servos were set up. I wanted one of them to be reversed because in reality they are reversed to each other, and that reversal should take place in the reversing section right there and not in the mixer. It can take place in both, but I think reversing should happen in the reversing specified reverse tab rather than in the mixer. So let's have a look at what I did here. First of all, I changed a few values here. You can see that my maxes have changed. The mins have not changed, those have stayed the same, which is nice. But the max value has changed, and that max value is just related to the topmost position. So my top position was almost correct, and I just changed that, made sure that it's basically perfect. And when we go into the mixer tab, you'll see that I made a couple of other changes. First of all, you can see now that where previously I had -83 and +83, I now have -83 and -83, which makes sense, as in both are fixed at -83%, which equates to a value of 1085 picoseconds. That is when I have the switch in the down position, which is for me vertical takeoff. Then I transition into transition mode, which is 45 degrees, and finally into plane mode. So this way I think it should work a bit better. And if we have a look at this here, you can see that that stayed. However, the values, as I said, the values stayed, but the sign has changed, and something where I had to change the sign as well was this here. It was -35 and -35. Now it's -35 and +35 because they are going in opposite directions rather than in the same direction. And that's the way that it should be because it makes sense. Additionally, the mixer transition shows -100, shows 100 for this, which means 100 is in the topmost position, and then when we flick the switch, they go into another mixer, which is the plane mixer, and here we can see that they are also at maximum 100 rather than what we previously had. So those are just a couple of the changes that I've made to this. You'll be able to download my diff or dump or both in the description, from the description below. I hope that this video was useful. These couple of changes shouldn't make much of a difference if you set it up the way that I showed in the first part of the video. Then hopefully this section makes sense as well. So yeah, thanks for watching. I don't want to keep it any longer than this is already. And yeah, I hope you learned something.